I am going to talk today about binary APIs, but in honor of our 8-bit theme today, I want to ask how many of you remember presentations done with transparencies? How many of you actually gave a presentation done with transparencies? All right. I haven't done many. One of my last significant presentations was still using transparencies. And I discovered recently that I still have some sitting on my bookshelf. And when you have a laser pointer, one of the things you naturally want to do with it is try the double slit experiment if you're a geek. And I realized if you try to read on the internet, how do you do the double slit experiment? People tell you, take a microscope slide and put it over a candle flame until you get a nice coating of soot, and then use a razor blade to scratch 2 little slits in it. It doesn't work. But if you take a transparency, you can print blocks of black ink onto it and just leave a little slit behind it. So, okay, if you turn around, you might be able to see a diffraction pattern, which might be cooler than anything I'm going to talk about today. Okay, so that's just a laser pointer dot. And if I shine it through this little double slit, whoa, look at that. It spreads out and you can sort of see some dots there. Okay, I just wanted to do something fun. My son took that to a science fair, and that was a fun project for us. I could go on and on about how to actually, the PostScript code I wrote to generate these little blocks, but that would be JSConf. And okay, so today, bytes and blobs, HTML5, and by HTML5 I mean HTML5 plus all the other stuff that kind of surrounds it, all the various specifications that are being developed in tandem with it. Enable a lot of new things where you can actually deal with bytes instead of characters. That's what I'm going to talk about today. But when I was trying to figure these out, there's a bunch of them. There's a blob, there's something called file object, there's a blob object, there's typed arrays, there's array buffer, there's array buffer views, typed arrays, and then some magic URL stuff. And it really didn't make much sense to me. And I was writing about this in the last chapter of the new edition of my book, and trying to figure it out. And finally, I came upon this figure, and this is in chapter 22, a version of this. And it made sense to me finally when I put it together this way. And I wanted to do this talk, just one giant SVG figure that would just dive into it and have animation and stuff, but I don't. I just have a bunch of slides. But, okay, so blob is this thing in the middle. It is an opaque representation of a chunk of bytes. It lives on disk. And all these things around the outside are sources or sinks of blobs. And we'll go through them today and fill in some details about what all those arrows do. You'll notice my one nod to, oops, that was the wrong button. My one nod to 8-bit. We'll just have a few of those in this talk. So starting in the upper left there, the web. Obviously, you can download blobs from the web. You can upload them to the web. Straight up is URLs. You can take a blob. Notice this arrow is just unidirectional. You can take a blob and convert it into a URL. And one of the coolest features that I'm going to talk about today, you can get blobs out of the file system. And in a brand new feature, you can actually write blobs to the file system. You can take a blob, extract the text from it. You can take a blob, extract the bytes from it into this array buffer typed array thing there. And once you've gotten text out of a blob or bytes out of a blob, then JavaScript can manipulate those values. So we'll talk a bit about that. We've got a black hole here where you take a blob and you can transfer it to other execution contexts, other web workers, or into other windows. And finally, the IndexedDB API also supports blobs, so you can send a chunk of data, a blob of data to, that's not supposed to happen. Okay. I thought I turned my screensaver off. Okay, let's move along and see about blobs. The blob API is really, really simple. Blobs have a length. Optionally, they have a MIME type. And they've got a single method where you can slice them up. It's kind of like substring for blobs. But they're opaque. There's nothing in there that's going to let you access any of the bytes. We're going to get to how you do that. I should also say that most of these APIs are not ones you're going to be using today. But I'm hoping that a year from now, these will be usable in the current crop of modern browsers. I'm going to have just a few live demos, and they do everything I'm talking about seems to work either in Firefox 4, Chrome 11, 12, and I'm running ThinkPad here. I didn't test them in Safari, but I think mostly the ones that work in Chrome, some of them work in Safari also. Okay, so BLOB obviously is from database terminology, binary large object, if you don't already know that. And the fact that it sits there in the center of that diagram, it's the interchange mechanism for all of these other sources and sinks of binary data. So I'm going to run through a few possible use cases. Here's one where you let the user select a file from their local file system, and you get that file as a blob, and upload it to the web. So that's just a real simple thing that we might want to do today, but using these new APIs. Okay, here's one. You download a blob from the web, and then you can, once you have that blob, you save it to a local file, or you might save it to an index database. So this is sort of a scenario for locally caching data. And of course, the right way to do that is probably with the new application cache, but you could do it this way if you chose to. So here's one of the ones that I like the best. You get a blob, which might come from the file system, and pass it to this magic URL creation mechanism that I'm going to talk about, and you get a blob URL, which you can then send into the DOM and do things with. So the obvious case is to have the user select an image from their hard drive, and then you display it in the web page, not through a file URL, which you'd run into permission difficulties, but just you convert it to a magical blob URL. In this scenario, you're using JavaScript to create an array of bytes, converting those bytes into a blob, and then again passing them through into a URL and doing something with them. Synthesizing audio is one example. I wanted to have a demo, but it works in Chrome, and I'm doing this presentation in Firefox, so no sound today. It's for the best, really. Here's a scenario where you're getting a blob from the web or from a file, converting it into, looking at the bytes, passing those bytes onto JavaScript, and doing something with them. You could get an image file, a JPEG file, look at its metadata tags, and figure out what kind of camera it was taken on, for example. Really get down and manipulate those bytes. And you can do that today with binary strings, but it's really awkward. Binary strings, if you use them, because JavaScript is Unicode, it's going to take 2 bytes for every actual byte of data. You avoid that with this. Now, you'll notice there's one little side step, little side path here, where you can actually go from the web, bypass the blob, and go directly to an array buffer. And I'll show you that. Okay, I just went kind of crazy with the arrows here. So we ask the user to select a file from the file system, get it as a blob, pass it through a black hole into a web worker to work in the background. That web worker takes the blob, turns it into an array of bytes, processes it somehow, turns the processed bytes back into a blob, and sends them up to a URL to the DOM or uploads them to the web. So this would be like client-side image processing. Are we going to get Photoshop in JavaScript? JavaScript's getting fast. We've got these background threads now, ways of working with the bytes. It could happen. Okay, so files is the most simple of the APIs that use blobs because files are blobs. File is simply a subtype of blob. It adds 2 new properties. Files have a name. Optionally, they have a modification date if your operating system provides that information. Notice that not all blobs are files, although one of the things about blobs is that they are, the API is designed with the file system in mind. So you've got to assume if you've got a blob that it's stored on disk somewhere. All the APIs that use them are going to be asynchronous because, God forbid, you wouldn't want to stop the JavaScript thread while the disk I/O runs. In practice, I assume that some implementations for small blobs will just store them in memory. If you're just creating your own blob with a little bit of data, convert it to URL, hopefully it never touches the disk. But blobs could also be really large. It could be a streaming or non-streaming video download or something, and it wouldn't even fit in main memory. So blob APIs are going to be asynchronous because of that. But all files are blobs. And the way you get files is the way we always have. The simplest way is just with a input tag, input type equals file. And what's new, instead of just doing an upload, those used to only be good for uploading files through an HTML form. But now you can actually get this, keep pushing the wrong button on my pointer. There we go, this.files. So when the change event occurs on that input tag, the files property of the input tag is a list of selected files. I didn't put a multiple tag up there, so there's only going to be one of them. I'm selecting number 0. I'm passing it to a hypothetical method called process. The other way to get files is with the new drag and drop API that IE implemented a long time ago, but HTML5 has now sort of blessed IE's implementation and is making it better, but hasn't gotten there yet. Or no one's implemented the better stuff yet, but the drag and drop API seems to work sort of in most browsers now. So when you get a drop event, the event object has a data transfer property, and that data transfer object has a files property, which is an array-like object of file objects, and you can pass those to something. Now, in this case, because the user has selected a file, either through a file input tag or with drag and drop, the user has implicitly given permission to use that file. And in the old days, they were given permission, obviously, to upload that file to a server. But from a security standpoint, it's the same thing as giving permission for your client-side code to look into that file and mess with it. Now, later on in the talk, I'm going to talk about private file systems that are enabled by one of these HTML5 APIs. And I apologize that I really thought I had disabled that. OK. Oh, there it goes. So files are blobs. Blobs had two properties, size, the length, and the MIME type. Files had two more, a name and a last modified date. So here's an example. It allows the user to select one or more image files. And when they select them, it just does a console.log and prints out the 4 properties of each of the selected files. That's about all you can do with the blob and file APIs directly. But things get more interesting. Well, OK, here's the upload scenario we were talking about. So you get a file. Right, OK, this slide doesn't show how you'd select the files, but these are you select files with a drag and drop or with an input tag, pass them to functions like these. The upload, pass it a URL and a blob. Now this would work with any blob, not just a file, but so far the only way I've shown you to get a blob is from a file. And you pass it a callback function. It creates a XML HTTP request. And what's new is we're now talking about the level 2 XML HTTP request, and this is beginning to work in browsers. Not everywhere yet, but so using it like a normal XHR, open the URL to do a post, and to the send method, I'm passing a blob. That's blessed by XHR2. You can now pass blobs to that, and it just uploads. Notice this next line there, r.upload. R is the XHR object. It's got an upload property, and it's got an onProgress event. Now this is really sweet. We no longer have to use onReadyStateChange. Once we've all got XHR2, we have normal event handlers like onProgress and onLoad for when it's done. We even have this set of upload objects. If you're doing a large upload, I apologize for my screen blanking. That really, I don't know. OK. So now you can track upload events. If you're doing a large upload like we are here, you actually get progress, and you can display little, you can use a little progress element or whatever to give feedback to the user on that. It would also generate a onLoad event when the upload is complete. If you just did r.onLoad, you would get an event when the download was complete, when the response was complete. This second function, upload files, expects an array-like object of files. And obviously, if you're uploading more than one file, you've got to do multi-part form data encoding, because you can't just munge them all together. They have to have separate names and types and such. But XHR solves this problem with this new form data object. So in order to upload multiple values with this multi-part encoding, or just multiple files, you create a form data object, and you append things to it. This append method, you give it a name, and you give it a value, and then you just pass it to the send method. So XHR has become more versatile for uploads and also for downloads. The little inset image shows the blob coming from file or the web and going to JavaScript via, I'm just showing the piece of it, there's the web, getting a blob from the web. This is implemented by, or specified by XHR2. Firefox does not have it yet. Chrome does, but not fully yet. So get blob, you pass it a URL, you give it a callback function, it creates an XHR object, does a get method for the URL. But before it sends this request, it sets this new response type property and says, we want this as a blob. I'm not interested in text. I don't want you to parse it as an XML document. I just want a blob of bytes. And then you call send. This is a get method, so there's nothing we're passing to send. When we get the onload, I was telling you about these new event handlers, no on ready state change. Onload, this function is called, we just use the response property there, r.response. No more response text or response XML, it's just response. You specify the type of response you want, and when you get the response, it's just in the response property. Now, what's buggy about this in Chrome is that the blob type isn't implemented. In Chrome 12, they've got a bug filed on it, they know about it. You use array buffer instead. Damn. Use array buffer instead, and that's this little side route here. You're going from the web directly, bypassing the blob, and we're getting down to this array buffer here. I'm going to talk about those soon. But before I do that, I'm going to talk about creating these URLs for working with blobs as being able to pass blobs into the DOM. There's a new URL object in Chrome currently. It's WebKit URL. And eventually, that might be a whole API for parsing URLs, working with URLs in interesting ways. Right now, it's just an entry point for, it's just a namespace for this create object URL function. And so you pass a blob to this function, it returns a string to you. This string is going to begin BLOB://. It's a new URL scheme. And what's interesting is your web browser is actually going to act like a mini web server when a blob URL is requested. They're quite different than file URLs. You don't have, they've got origins, so there's a security policy for them. If the blob that this URL references no longer exists, you'll get a 404. If there's a cross-origin thing, you'll get a the 403, whatever the appropriate security HTTP error is. So they play really nicely with HTTP. And there's also does it seem to you guys that this timeout is getting shorter and shorter? When you're done with the blob, you should revoke the URL. I don't fully understand it, but there's a memory management issue there. The string, the mapping of these, the blob URL is really short. I didn't say that. 40 characters or something. It's going to have a GUID after the blob : // and there's a mapping from that GUID to the blob stored on disk or stored in memory. But you don't want to force the browser to keep those things around if you're not using them anymore. So you can call this revoke object URL when you're done. Okay, so this is the scenario I promised you where you get a local image file, get it as a blob since files are blobs, turn it into a URL, pass it up to the DOM, and display it. So we've got a file selection box to select a file, and a function display. It takes an element and the file. It's going to create a new image tag, sets the source of that image tag to the blob URL derived from the file, sets an onload handler on the image so it can then cancel that blob URL once we're done using it, and it does a replace child. And look at this, it's live. Let's try, I'm going to browse for a file. Oh, here's one on my desktop. Oh, look at that. So, local file displayed in the web page. Okay, it starts to get more interesting. We've been talking about blobs all this time without ever looking at what's inside the blob. This is where we start to be able to do that. There is an object called file reader, or a new type called file reader, and it has methods to get the content of a blob. Read as text, read as binary string, read as array buffer, read as data URL. Read as text obviously decodes the blob content as a UTF-8 string. Read as binary string is only if you want to do it the old, dirty way, actually convert each byte into a 16-bit UTF-16 character and do it. But you don't need that because we've got read as array buffer now, so you shouldn't need to use read as binary string. And read as data URL gives you a data : // URL, which is different than a blob URL, and you don't really need that either now that we've got this URL create object URL. Now, these are all asynchronous methods. I told you that blobs live on disk. You can't just get random access to them. So you call these methods, but then you define an event handler to wait until the content is actually ready. So here's how you'd read a text file. Once again, I just have an input for select a file. You pass it to this function read. It creates a file reader object, then passes the file to the read as text method, defines an onload handler. When that onload handler is called, the text is available in the result property of the reader. If I had called read as array buffer, then the result property of the reader would be an array buffer object, and we'll talk about that next. So all I do here is I take that text, stick it into a text node, put it in this ID equals output thing up there. I'm going to stick the text into there. And this one is also live. So let's browse for a text file here. Oh, here's an important message. You've died of dysentery. OK, so again, local file, JavaScript reads contents as text, displayed it in the web browser. So read as array buffer is a lot like read as text, but the result object is an array buffer. So what is an array buffer? Like blob, it's got a very minimal API. All you can do with it is find out how long it is. An array buffer is an opaque representation of bytes, but these are bytes that are in memory rather than on disk. So we do have the option of getting random access to those. In order to do that, though, we need to wrap an array buffer view around the array buffer. An array buffer view itself, hey, how many of you have noticed that this stuff isn't actually JavaScript? I didn't mention that when I'm showing these interfaces, this is WebIDL, of course. That's what all the specification languages are written in, and I figured you'd all figure it out. So array buffer view is sort of an abstract interface that all views of array buffers implement. It gives you a reference back to the buffer object itself, and optionally, when you create a view, you can specify what portion of the array buffer you're interested in, given a starting offset and a length. So you can substring your array buffers if you only want to look at a piece of them. Now, the most interesting array buffer views are the typed arrays, and that's on the next slide. OK. There are 8 typed array types, and all of them are array buffer views. int8 array is an array of signed bytes. uint8 array is an array of unsigned bytes. int16 array is an array of 16-bit words. uint array is an array of unsigned 16-bit words, and so on. They've got 1, 2, and 4 byte integers, and then you've got 4 and 8 byte floating point numbers. So when you create one of these around an array buffer, it's going to treat that array buffer as just a straight array of that data type. If your array buffer actually contains mixed up different values, you can create lots of these views over little parts of it, or on the next slide, I'll show you an alternative. So here's a little bit of code to look at. Bytes equals new uint8 array on buffer. That's just, here's an array buffer. It's pretty opaque. Bytes now is an array-like object. It's got a length. It's got elements. You just treat it like an array. But each element of that array is going to be a value between 0 and 255. Here's slightly different. It's still a uint unsigned bytes, but this time I'm only looking at the last 1K of my buffer. And here we're using 4-byte integers. And this time I'm not passing it a buffer. I'm just telling it that I want. OK. In this last one, I'm just telling it that I want 4,096 4-byte integers. It's going to allocate the 16K array buffer in the background. If I want it, I can get it out of inst.buffer. We'll refer to that buffer object that's been created for me. One of the things that's really important to understand about typed arrays is that they use the native endianness of your platform. So this int32 array, it'll just work if I'm keeping it within JavaScript. But if I try to take those bytes from that array buffer and send them across the web, they're going to be little endian or big endian, depending on my particular browser. If I try to save them to a file and then access that file from on a different platform, you can get endianness issues. So typed arrays you really have to be careful about. All these typed arrays came out of WebGL, and for WebGL, they just want to use native endianness for speed. But they don't quite fit our needs if we want to do interesting things with our bytes and have control over big endian or little endian. There is another kind of array buffer view, however, it's called DATAVIEW, which gives us that control over endianness. And it also doesn't force you to treat your array buffers as single arrays of all the same type. You just tell it what offset you're interested in and what type of value you'd like it to extract or what type of value you'd like it to read. So you can wrap a data view around your array buffer and then start pulling things out of it. Here I'm asking for a 4-byte integer at offset 0. DATAVIEW defaults to big endian because a lot of network protocols use big endian. I'm going to turn it around the data.setInt. So here I'm writing the integer. I'm writing the same one I. I pass this true argument, and that's going to give me little endian. Same thing for floats. You can get, I'm getting an 8-byte floating point value starting at offset 4. I stick in true, so I'm getting little endian. Here I'm doing a 4-byte float at offset 12, saying it's a big endian. I think the DATAVIEW API is terrible, but it at least does what we need. There's an improvement. It's easy to improve upon. You can, you want a little more streaming. It's easy to get it to keep track of the offsets yourself. It's not too hard to add UTF-8 encoding and decoding so that so you can get strings out of these array buffers. Oh, you're still blank. It came back over here. There we go. I put something on GitHub that's just starting some experimenting around with a better API for it. And one of the examples in this GitHub repo that I'm not doing here is load a zip file, use my buffer view class, which is just a wrapper around DATAVIEW, to inspect the bytes in it, find the contents of the zip file, and list them. Pretty simple example, really. OK. In our diagrams, with the things we could do with blobs, all these bidirectional things, I've just talked about how to get text out of a blob, how to get bytes out of a blob. But all those arrows were bidirectional. So how do you take text or bytes and create, stick them into a blob? Well, you do that with an object called blob builder. In Chrome 10, it was just blob builder. Chrome has gone and stuck WebKit prefix in it kind of in a backwards way. And so now it's WebKit blob builder. I assume by Chrome 14 or something, we'll be back to blob builder, I hope. So you create one of these, create a new blob builder, and then just call it its append method. You can pass strings in, you can pass blobs in, you can pass array buffers in. And then when you're done concatenating all your text and your bytes together, you call get blob. Optionally, you can pass a MIME type to get blob, because as you remember, blobs have a length and optionally a type, so you can specify that type for your blob. And then once you have a blob, you can do anything you want with them. So one of our other scenarios was using JavaScript to get a whole bunch of bytes, convert them to a blob, convert that blob to a URL, and do something with it. This one's not going to be live, but this is what the code looks like. This big data structure is header bytes for a wave-encoded audio. You don't have to care about any of the details here, except, so this is just a regular JavaScript array, square brackets down here and down here. But I'm passing that array to new uint8 array. So I'm converting my array of JavaScript numbers into an array of bytes. And the way down here, I'm calling .buffer. So I created the array, initialized it with all these numbers, and then I just want the actual array buffer out of it. So I'm abstracting away from the actual array. And let me back up a slide here. I wanted to tell you, these typed arrays, if any of you have used the canvas tag and have messed around with the canvas pixel array, if you could do a get image data on your canvas, inside what you get is an array-like object of bytes. It's very similar to these uint8 arrays, and they work fast the way you would expect them to. The small difference is that the canvas one, I think the spec requires it to be clamped. So if you try to store value 256 into a canvas pixel array, it's going to clamp it to 255. whereas in a uint8 array, I think it would roll over and you'd get a 1. Or you'd get a 0, yeah. Okay, forgot to mention that. So here, this first slide of audio synthesis, we just create this big old array buffer that holds the header of the WAV file we want to generate. Now, I've got some code up here at the top of the slide that just deals with prefixes for blob builder and the URL thing. So then a function makeWave, you pass it an array buffer of samples. It creates a blob builder. It creates a DATAVIEW wrapper around that header object that we created on the last slide. And then uses these setInt32s to stick in the length of the samples. That was the one thing that was missing from the header, is the data, is the numbers that say how big the file is going to be. So we stick those in with the DATAVIEW object. And then we use the blob builder. We append the header to it, and then we append the samples to it, and call getBlob on it to return a blob with the MIME type audio/wave. This function returns that. So on slide 3, you'll see what we do with that. So here's the function playNote. You give it a duration and a frequency. It does some math to figure out how many frequencies, or how many cycles, how many samples per cycle. So if we pass in 440 hertz to get a concert A note, it does the math, does a little for loop here. So it creates a new uint array. The header hard-coded, I'm not doing a real fancy thing here. The header I showed you hard-coded 20,000 samples per second at 1 byte per sample. So we're hard-coding that in here as well. So the duration in seconds, if it's a 1-second note, it's going to be 20,000 samples in this array of, this typed array. This for loop initializes those samples, passes it to that makeWave function from the previous slide to create a blob. Then we call URL.createObjectURL on that blob to get the URL. Create a new audio object. This is just the constructor. The HTML5 audio tag, I guess by analogy to the HTML5, or to the old HTML image tag, has this audio constructor, just like the image has an image constructor. I'm not exactly sure why that was necessary. I could have just done new element, or document.createElement audio, and that would have worked, and I could have just set the circ property to URL, but it's easier this way. Call play on it. I've added an event listener for the ended event on the audio tag, so that when it's done playing, I can revoke the object URL. And this actually works on Chrome, but I'm not going to demonstrate it for you. It just goes beep, and it sounds very 8-bit. And obviously, if you were wanting it to make it sound nice, you'd add overtones. You'd do some more complicated math here to get more interesting waveform and higher sample frequency and such. Okay, at the beginning of the talk, I promised you that using the HTML input tag and drag and drop are not the only ways to get files. Those are user-selected files. HTML5 and these file specifications now allow a web app to have its own local file system. This is going to be private to the web app. Other web apps aren't going to be able to see it. Web app's not going to be able to escape from it and start looking at the real files, but web apps can have their own file system. And it's an incredibly heavily asynchronous API, annoyingly so, but it works. When you use it in Chrome, you want to start Chrome up with these unlimited quota for files. Right now, Chrome won't ask the user for permission to use files. It just only works if you start it with this. I assume that eventually the need for that command line option will go away, and Chrome will start asking the user, hey, this web app wants to create files. Allow file access from files you have to do with Chrome if you want to experiment with it on your local drive rather than running from a server. Okay, so load blob, this function is going to load a blob from the local file system. The first thing you do when you want to use the local file system is called request file system. In Chrome currently, we prefix it with WebKit. The first two arguments are either the constant persistent or temporary, which do is what you'd expect. A persistent file system persists across sessions. A temporary one is one time, this session only. Then you specify how big a file system you want. And I guess the point is that when the user is asked for permission, it will specify how much quota your web app is asking for. Since we've specified unlimited quota, it doesn't really matter currently. And then the next thing is, of course, the callback that's going to get invoked when asynchronously your file system is ready. It's async, of course, because the user may need to grant permission. And of course, this is kind of a little backwards, since before anything is in that file system, we would have had to create the file system, get user permission, and write a file to it. I'm showing you the reading file first, but you still have to call this request file system to get a handle to that file system object. And that's what's passed to this function here, function fs. So when this function is called, we've got a file system object. So then we can get its root object. That's synchronous. So that's just the slash directory of the local file system. We call get file. Now, nomenclature is tricky here because we're not actually asking for a file. We're requesting a file system entry. So we pass the path. This is the path that was passed up here. So we tell it what file we want. This is an options object. It's empty in this, for this read case. And then we pass the callback. When this function is called, we are going to have an entry object. The function is called getFile, but really what it is request file system entry. The entry in a file system it points to the file, but it's not the file itself. So then we have this entry callback, and with it, we call its file function, which says, please give me the actual file object. And we pass the callback to it. When this callback gets called, we finally have this object f, which is the actual the file object, which is a blob, and we're passing it to that callback way up here to do something with. So the obvious other piece of it is how to write local files. And you can see down here in my inset image, this was the use case I was talking about. Download blob from the web, store it to a local file, for example. So this is a lot like the load blob, but it's the writing case. We started off again requesting a file system. This case, and we're saying it's persistent, we want 50 megabytes. And in the writing case, it seems like you'd expect that to matter a little bit more. Oops, sorry. Okay. Again, we have a callback function that gets invoked when the file system is ready. Again, we call getFile, which really means request file system entry. We pass the path. This time I'm passing something in the options object, create : true, which means if the file doesn't exist, go ahead and create it. Without that, it would just return an error saying, can't write to that file because that file doesn't exist in the file system. And so this callback will be called with the file entry, the file system entry object when we've got it. Instead of calling file to get the blob, we now call create writer. And this creates a file writer object. And again, async. When this function is called, we have a file writer object. Now we can write a blob to the writer and specify callback if we want to know when that write is done successfully. I have been omitting in all of these slides the error handling code. And of course, you won't do that when you use these APIs. You'll be good about registering your own error handlers and dealing with all the things that can go wrong. But to fit on a slide, I'm just ignoring those. What could go wrong? So that's how you write data to a local file. And this actually does work on at least Chrome. I forget whether it's working in Firefox right now. But I don't have a demo of it. Okay, remember in the lower left corner of my magical diagram, the black hole, where you can take blobs and pass them into other contexts. Blobs can be used as messages, and HTML5 does a lot of message passing in a couple of different places. It does that, and defines something called the structured clone algorithm, which is kind of like JSON serialization of objects and arrays, but it also defines a few other types that can be serialized, including canvas pixel array from the canvas tag and blobs. So if you are working with a web worker, you can pass a blob to it just by calling post message on the worker object. And if you are working with a worker and it wants to send you a blob, you can just register an on-message handler like you would with any worker. And, the data object you get back can be a blob. In the worker, things are pretty much the same. You just define the global post message, or call the global post message to send a blob to your parent. Define the global on-message handler to receive messages from your parent, and those might be data objects. HTML5 also defines cross-origin messaging, where two windows can communicate even if they're from different origins through this safe message passing. And because everything is cloned, the structured clone algorithm, that makes it safe because no live data is, I mean, it's only copies of data, so they can't modify each other's state. They can just pass messages. Not all browsers, I think, yet support this for cross-origin messaging with text, some of them with blobs. But that's the idea. You should be able to do that. You should be able to pass a blob onto another window, and Windows can receive blobs. You always want to check in cross-origin messaging whether the message you get is actually from the origin that you were expecting it to be from. But if it is, then the data object might be a blob if that's the message you were expecting. Okay, and over on this side of my diagram, I showed the IndexedDB. I'm not going to go into that API in any detail because it's really complex and kind of off in the weeds a little bit. But you can, in fact, store blobs to the index. Oh, sorry, I forgot this first bullet point is about the local storage and session storage, which are kind of really simple databases for client-side storage. In theory, you should be able to just assign blobs to that. The HTML5 spec says that the structured clone algorithm is used for this. In practice, browsers, I think uniformly, browsers currently only support strings for local storage and session storage. Hopefully that'll change. The spec says that they're supposed to do any object or array or blob you should be able to store in local storage and session storage. While we're waiting for that, though, if you want to use the more complicated IndexedDB, that's beginning to work in the latest browsers. And it's a it's a heavily asynchronous API. Eventually, you get this object store object, and you can call a put method on it and store a blob in an object store. And you can create requests. You get an object store, you call get on it, and that creates a request object. And if your request is successful, you can get a blob out of it. But there's a lot of other layers of that API that I'm not going to try to cover now. Okay. So, just about done here. So back to my figure that I like so much. All I've done here is filled in the details that we're talking about. For the web, you can download blobs just by setting that response type property on the XHR before you send the request off. And then when you receive the response, that response property, an XHR2 will have your blob. If you want to upload a blob, just pass it to the send method. If you have multiple blobs you need to upload, use that new form data object. If you want to take a blob and let the web browser manipulate it directly as part of the DOM, you turn it into a blob URL with create object URL. Or use this file reader.read as data URL if it's small enough and you want to deal with data URLs. If you want to, well, files are blobs, so it's pretty simple. If you can get a file, then you have a blob already. If you want to write a blob to the file system, you call request file system and go through the asynchronous hoops where eventually you get a file writer and you can store your blob. If you want to read text out of a blob, you create a file reader. You call read as text on it and asynchronously get the text. To go the other way, you create a blob builder, append text to it. If you want to get bytes out of your blob, you create a file reader again and do read as array buffer, or reverse, again, use a blob builder. Sadly, there's no way to go between array buffers and text. There really ought to be an arrow back and forth here. And that's one of the things I wanted to address with that GitHub project I pointed you at, is have UTF-8 encoding and decoding so that you don't have to go around this way. Post message and on message just work with blobs. You can store blobs to the IndexedDB if you want to go there and figure that API out. And that's all I've got.
Happy trails to you until we meet again.